April 22, 1915. 5 o'clock in the evening. The wind over Ypres shifted, turning its back on the German lines and blowing west. Along a 6-kilometer front, the French and Algerian sentries squinted into the sun. They saw no shells, no heavy artillery. Instead, a wall of yellow-green mist rose from the German trenches. It moved slowly, silently. It clung to the grass, flowing into every dip and hollow in the earth. The soldiers watched, mesmerized by the anomaly. Was it a smokescreen for an infantry charge? What was this wind carrying? 160 tons of pure chlorine. The scale was industrial. German pioneers had spent weeks buried in the mud, hiding 5,730 gas cylinders in secret. A single hand turned a metal valve, then another. A hiss filled the air. In 5 minutes, the Germans released a weight of poison equal to 20 empty London buses. The cloud reached the Allied lines. It was a physical force. The gas reacted with the moisture on the soldiers' uniforms. Polished brass buttons turned a dull, sickly black in seconds. The mist rolled over the parapets and poured into the dugouts. Men trapped at the bottom of the trenches saw the green fog descend like a heavy liquid. No one had masks. No one had protection. A sharp, stinging scent hit the air. It was the smell of common household bleach, but concentrated 1,000 times over. The soldiers recognized the odor of a laundry room just as their lungs began to burn. What soldiers inhaled over the fields of Flanders was no longer air. It was a chemical reagent. Chlorine gas is heavier than the atmosphere. It does not dissipate. It hugs the earth, sliding into shell holes and sinking into the deepest dugouts. The molecule seeks one thing: water. Chlorine is highly reactive. Upon contact with moisture, it undergoes an immediate chemical transformation. The formula is simple. Cl2 plus H2O equals HCl, hydrochloric acid. The reaction triggers instantly on any damp surface of the human body. The eyes burn first. The membranes of the nose and throat dissolve. But the primary target is the lungs. Inside the chest, a thin film of moisture coats the alveoli. This is where oxygen usually enters the blood. When chlorine reaches these microscopic sacs, it turns their lining into acid. The biological response is violent. Tissue inflames. Capillaries leak. The body attempts to flush the irritant by flooding the lungs with its own internal fluid. Listen to the sound of the trenches. Medical officers called it dry drowning. It is a wet, gurgling struggle for air as the lungs fill from the inside out. The mechanics of the death are purely physiological. It is not a standard poisoning. The acid creates a barrier that blocks all gas exchange. The heart pumps faster to compensate for the lack of oxygen. It fails. The victim suffers from acute hypoxia followed by total asphyxia. The official medical cause of death is drowning on dry land. 6,000 kilometers of Western Front trenches had never seen a collapse of this scale. Organized defense vanished. Animal panic took its place. The 45th Algerian Division held the line near Langemarck. Captain Georges Lamoureux watched the green clouds swallow his men. He reached for the field phone. One last message reached headquarters before the line went dead. Lamoureux stayed at his post. He died while reporting the breach. While the soldiers' alveoli filled with fluid, the front line simply ceased to exist. Why did the defense fail so fast? The lungs turned into a chemical furnace. Men stumbled from the trenches with gray skin. Their eyes bulged. They clawed at their throats, trying to outrun an invisible killer. Most collapsed within a few yards. In 10 minutes, the entire French and Algerian sector was erased as a fighting force. 1,000 men died instantly. Another 4,000 suffered severe internal burns. A gap 4 miles wide opened in the Allied line. No breakthrough of this magnitude had occurred since the start of the war. The German infantry moved into the void behind the cloud. The number of dead and incapacitated reached 5,000. The German infantry of the 23rd Reserve Corps stepped into a 6-mile void. Their only protection was gauze pads soaked in sodium bicarbonate. The soldiers pressed the wet fabric to their faces. They had been told the gas would clear the path. They only had to follow. Why did they stop? fear of their own creation. The Germans moved through the green haze. They saw the results. Bodies lay in positions that defied natural death. Faces had turned a deep, necrotic blue. The scale of the agony stunned the attackers. This was no longer a tactical maneuver. It was a descent into an industrial slaughterhouse. The gap in the Allied front was 4 miles wide. The road to the city of Ypres stood open, but the German command had not prepared follow-up divisions. They did not expect such total devastation. Doubt took hold in the trenches. No one knew if the soil itself was now poison. The edge of the chlorine cloud had already caught their own men. The advance slowed to a crawl. This hesitation would save Ypres, but it would not save the war from escalation. The German infantry stopped and began to dig in. The German infantry dug in, but the weapon they unleashed did not stop at the trenches. The heavy yellow cloud clung to the earth. It flowed like water into the lowlands. The gas drifted toward the outskirts of Ypres. It did not distinguish between a soldier and a child. The chlorine settled into cellars where civilians hid from the shelling. It filled the stables of nearby farms. Thousands of animals died in their pens. In the villages downwind, people woke up choking on their own melting lungs. On the Allied side, the front line had a 6-kilometer hole. Commanders scrambled to plug the gap. They were paralyzed, not just by the corpses, but by the collapse of the old world. Chemical warfare was a direct violation of the Hague Convention of 1899. But law meant nothing in the path of the cloud. The reinforcements had no protection, no masks, no filters. They had to improvise. A soldier took a piece of scrap fabric. He urinated on the cloth. He pressed the wet, stinging rag against his face. Ammonia and chlorine collided. It was an instinctive chemistry. The cloth smelled of sharp ammonia and bleach. The soldier inhaled through the soaked fabric. The ammonia neutralized the chlorine, turning the poison into chloramine. It was less toxic. It was enough to keep a man standing. They stood in the haze, breathing through their own waste. It was a humiliating survival. The dignity of 19th century warfare vanished in a reek of urine and gas. Reinforcements reached the line and held their breath. The German General Staff faced a strategic deadlock. They needed a breakthrough. They found it in the industrial surplus of chlorine gas. But a signature stood in their way. Before forcing soldiers to breathe through rags, Berlin had to bypass the document of 1899. The Hague Peace Conference was explicit. Major powers pledged to abstain from projectiles designed to diffuse asphyxiating gases. The 1907 convention reinforced this ban. Did they break the law? Not a single letter. The German legal team identified a loophole. The treaty prohibited gas shells. It banned projectiles. It said nothing about the gas itself. Fritz Haber, the future Nobel laureate, personally supervised the solution. He did not need cannons. Thousands of steel cylinders arrived at the front. Engineering units buried them in the parapets. No shots were fired. The method was simple. Open the valves and let the wind do the work. Technically, the gas was not a weapon. It was an emission. The German High Command concluded that since no projectile was used, the treaty remained intact. Lawyers searched for loopholes because generals on the Western Front had hit a strategic dead end. The war of maneuver was dead. The Schlieffen Plan lay in ruins after the Battle of the Marne. Millions of men vanished into the earth. From the Swiss border to the North Sea, the front line froze. The defensive had won. Machine guns created zones of absolute death. One Maxim, or MG-08, could stop a battalion. Artillery fired faster than ever before. Aircraft circled above, spotting every troop movement before it started. Every 100 meters of gained ground cost thousands of lives. It was a systemic collapse of traditional tactics. Why couldn't they just move? The technology of 1914 outpaced the human body. A soldier moved at 4 kilometers per hour. A machine gun fired 600 rounds per minute. The math didn't add up. General staffs across Europe faced a crisis. The infantry was becoming obsolete. Gas was not an act of sadism. It was an engineering solution to the problem of the machine gun. If a man could not be hit by lead behind a trench wall, the air around him had to be turned into a weapon. German chemists moved from the laboratory to the front lines. The Kaiser's army began the deployment of specialized pressure cylinders. The idea of flushing out an enemy like a rat existed long before the machine guns of 1914. It was an ancient logic. Poison and choking smoke broke defenses when steel failed. The Spartans understood this. During the siege of Plataea in 429 BC, they burned wood soaked in pitch and sulfur. They used the toxic fumes to clear the city walls. Isolating a garrison required simple methods. Attackers poisoned wells. They contaminated streams. These were improvised tricks, tactics for the margins of war. For centuries, such methods remained outside of formal military doctrine. Chemicals were a nuisance, not a strategy. By the turn of the century, chemists experimented with toxic agents. Officers watched the tests. No one was impressed. The equipment failed. The delivery was erratic. Culturally, the concept carried the stench of dishonor. Honor defined the 19th century officer corps. A rifle was a tool. Artillery was a science. Poison was a coward's weapon. It was sneaky. It was unfair. Military planners dismissed chemical warfare as a technical dead end. Before 1915, the High Command viewed gas as a breach of the professional soldier's code. The taboo was shattered. By the autumn of 1915, the British prepared a massive response near the French town of Loos. Chlorine was only the prototype. The German success at Ypres acted as a starting whistle for every major power. Research moved from the laboratory to the assembly line. Scientists began developing two deadlier agents to join the arsenal. The era of the industrial chemical race had begun. Following the first deployment, German forces launched 3 additional gas attacks in the same sector. They aimed for a total breakthrough. British and Canadian units suffered heavy casualties but held the line. The German momentum faded. The offensive stalled. Yet, the military calculus had changed forever. It was no longer an experiment. It was a system. The British military established a specialized gas warfare organization. Recruitment focused on chemists and engineers. By September, they moved thousands of cylinders to the front. The British planned to turn the wind into a weapon on a scale never seen before. They expected a swift victory to end the stalemate. Instead, they ensured a long chemical war. On the 25th of September, 1915, British special units opened the valves. Artillery crushed bones. Machine guns tore flesh. The trenches rotted feet. These are the classic images of the Great War, but chemical weapons occupied a different, darker space in the soldier's mind. The Battle of Loos proved a vital point. What began as a desperate experiment fast became a battlefield routine. Artillery and machine guns were instruments of kinetic force. Gas was an instrument of systematic agony. It did not just kill. It attacked the human body with a methodical cruelty that steel could not match. The statistics tell a strange story. 90,000 soldiers died from gas. That is less than 1% of total wartime losses. Yet the psychological trauma reached 100%. Every man in the mud lived in a state of permanent, invisible dread. This is why our investigation began with a warning. We are tracking the evolution of a nightmare. From the first valves opened in 1915 to the total industrialization of poison. By the end of the conflict, the chemical industry had transformed the very nature of survival. Total casualties from all causes reached 37 million. British High Command demanded a response. In the fall of 1915, they prepared a massive chemical retaliation. The target was the German lines at the Battle of Loos. The British lacked specialized artillery shells. They fell back on the German method. Engineers lined up thousands of cylinders filled with chlorine gas along the trenches. On the morning of September 25th, they waited for the wind. The plan was simple. Open the valves and let nature carry the poison toward the enemy. The wind shifted. In seconds, the green clouds rolled backward. Instead of suffocating the Germans, the gas engulfed the British positions. Chaos followed. Officers tried to shut down the operation, but logistics failed them. Someone had issued the wrong valve keys for hundreds of cylinders. Soldiers struggled with frozen locks while the gas pooled in their own trenches. Then, the German artillery opened fire. High explosive shells struck the stockpiles. Cylinders burst. Raw chlorine sprayed directly into the faces of the men meant to deploy it. The British wore primitive smoke helmets. These were little more than flannel hoods with glass goggles. They leaked. They suffocated the wearer. In the frantic rush to escape the gas, men tore the masks off. The tally was grim. On that morning, British chlorine killed more British soldiers than Germans. It was a technical disaster. The wind was too unpredictable for industrial warfare. Commanders realized the cylinder method was a dead end. They needed precision. They needed control. By the end of the year, the British military ordered the mass production of chemical-filled artillery shells. Artillery solved the delivery problem. Chemists solved the problem of visibility. Chlorine was too loud. Its green cloud and bleach stench gave the enemy seconds to react. They needed something silent, something invisible. Enter Phosgene. How do you kill a soldier who doesn't even know he's under attack? You use a gas that smells like a summer meadow. To a sentry in a damp trench, the faint scent of musty hay was almost pleasant. It didn't burn the throat immediately. It didn't trigger a coughing fit. The chemistry was a slow-motion trap. Phosgene molecules reached the deep tissues of the lungs. There, they met moisture. A slow chemical reaction began. The gas transformed into hydrochloric acid directly inside the lung cells. The damage was microscopic at first. The soldier felt fine. He ate his rations. He cleaned his rifle. He thought the attack had failed. Then the latent period ended. 4 to 24 hours later, the capillaries collapsed. Fluid flooded the air sacs. It was a dry drowning on land. By the time the first gasp for air came, the lungs were already dissolving. The scale was industrial. While mustard gas caused more scars, Phosgene delivered the most coffins. Statistics from the Great War confirm its lethality. 85% of all chemical weapon fatalities resulted from Phosgene. It wasn't designed to scare, it was designed to erase. Everything depended on the dosage. Doctors and field hospitals faced a wall of silence. Phosgene was a phantom. By the time a soldier started coughing, the damage was irreversible. Everything depended on the dosage. A small breath meant chronic lung disease. A deep one meant a death sentence. The wards were not quiet. Medical staff described gas casualties as the ultimate horror of the Great War. It was the sound of dozens of men drowning on dry land. A rhythmic, wet struggle for air that broke the psyche of seasoned surgeons. They saw the worst. They remembered it for decades. Could the medicine of 1915 intervene? No. Doctors stood by with empty hands. They had oxygen, but supplies were microscopic. Then came the waves. Gas casualties never arrived alone. They hit the field hospitals in hundreds, all at once. The logistics collapsed instantly. There were not enough canisters. There were not enough beds. Doctors watched men turn blue while waiting for a turn that never came. They could only provide a pillow and a witness to the agony. Phosgene filled the morgues, but the next chemical shift changed the goal. The new priority was not the grave, but the hospital bed. The German army deployed mustard gas. If Phosgene filled the morgues, the next substance was engineered to paralyze the hospitals. In July 1917, near Ypres, the German army deployed mustard gas. It functioned with a different surgical logic. Why use a weapon that rarely kills? To turn an entire army into a massive, immobile infirmary. Mustard gas was a blister agent. High explosives vaporized the yellowish, oily liquid into a fine aerosol. The mist settled on everything. It coated wool tunics, leather boots, and exposed skin. In the first minutes, there was no pain. Soldiers felt nothing. The chemical reaction was invisible. Molecules penetrated the skin and began destroying cellular DNA. 6 hours later, the agony started. Massive, fluid-filled blisters bubbled across the neck, armpits, and groin. Moisture accelerated the effect. Eyes were the primary target. The corneas burned and clouded. Thousands of men stood in long, blind chains, hands on the shoulders of the man in front, waiting for evacuation. Mustard gas had a fatality rate of less than 5%, yet it accounted for 90% of all chemical casualties on the Western Front. One dead soldier required a grave. One wounded soldier required 4 stretcher bearers, 2 nurses, and a hospital bed. The gas was heavy. It did not dissipate with the wind. It sank into the mud and soaked into the wooden duckboards of the trenches. This gas remained active in the soil for several days, but in the earth of France it would remain for a century. Mustard gas turned the soil into a minefield, but the mask broke the mind faster than the toxin. Every breath became an act of labor. Moisture from the lungs fogged the glass lenses. Vision blurred. The rubber seal bit into the skin. Inside the mask, the world narrowed. A soldier heard only his own heavy, rhythmic rasping. He felt the constant, gnawing doubt. Is the seal tight? Is the filter spent? The enemy began to hide the poison. They mixed chemical rounds with high explosive shells to mask the sound. To the untrained ear, it was just another barrage. Soldiers learned to listen for the difference. A standard shell shatters the air with a sharp, violent crack. The chemical shell was different. It carried no heavy explosive filler. Inside the thin casing sat a reservoir of liquid gas. A small burster charge occupied the center. Upon impact, it did not detonate. It popped. Veterans recognized that muffled, hollow thud instantly. It was the sound of a metal lung bursting. A single thud triggered the madness. Sentries hammered on brass shell casings. They cranked hand-operated sirens. They shouted through layers of rubber. The alarm signaled the start of the suffocation. Artillery tactics evolved to hide the chemical threat. Gunners began mixing gas shells with high-explosive rounds in a single barrage. This tactic masked the distinctive muffled thud of a chemical burst. Soldiers could no longer distinguish between a kinetic blast and a toxic release. Why was the dugout no longer a sanctuary? Physics turned protection into a tomb. Both phosgene and mustard gas have a higher density than air. They do not dissipate. Instead, they flow like heavy water, sinking into the lowest points of the landscape. The vapors crawled into trenches. They poured down into deep dugouts. Carbon steel and reinforced timber blocked the shrapnel, but they trapped the chemicals. The air inside became concentrated poison. A soldier faced a binary choice: stay underground and drown in caustic vapor, or climb out into the open and be torn apart by steel fragments. The infantry was trapped between a gas chamber and a meat grinder. Success meant choosing the method of your own execution. In the final years of the war, thousands of men died choosing between the explosion and the cloud. 1.3 million casualties. Only 100,000 died. For the rest, survival was a lifelong sentence. The horror shifted from the suddenness of the grave to the slow decay of the living. Industry replaced the individual. By the end of the war, all sides combined released 125,000 tons of chemical agents. This weight equals 3 Titanic-class battleships vaporized and sprayed into the lungs of young men. Scientists developed 39 different toxic formulations. Chlorine, phosgene, and mustard gas remained the primary killers. Scale dictated the strategy. At the start, gas was an experiment. By 1918, it was the standard. Every third shell on the front no longer exploded with a roar, it hissed. Production reached a fever pitch. Major powers fired tens of millions of gas-filled projectiles. Out of 1,500 million shells of all types used in the war, the chemical share grew relentlessly. But many failed to function. Roughly 30% of all shells fired by the artillery remained unexploded in the mud. 1.5 billion shells fell on the fields of France and Belgium. Millions did not explode, they simply sank into the mud. A tractor pulls a plow through the black soil of the Somme. The blade strikes metal with a dull clang. The farmer stops. He knows that sound. This is the iron harvest. Every year, the Earth pushes up hundreds of tons of rusted steel. Some shells are filled with high explosives. Others contain something much worse. The gas inside is still alive. After a century, the liquid sulfur mustard remains potent. Corroded casings have become thin. One fracture releases the toxin. It does exactly what it was designed to do in 1917. It burns, blinds, and kills. France designated 16 million acres as the Zone Rouge, the red zone. Entire villages vanished from the map. The soil was too saturated with arsenic and lead to sustain life. Even today, the state maintains strict control over these forbidden sectors. 630 French bomb disposal experts have died since 1946. They were not killed by a modern enemy. They were killed by a ghost from the Great War. Thousands of civilians have shared their fate. 13 million chemical munitions remain buried. They are silent. They are waiting. Time is now the primary enemy as the metal shells continue to rot in the damp earth. After the armistice, the problem remained. Millions of chemical shells sat in warehouses. The victors needed a solution. They chose the depths. Where did hundreds of thousands of tons of mustard gas vanish after the ceasefire? They went to the bottom of the sea. Dumping munitions into the ocean seemed the quickest escape. Military logic was simple. Water would hide the shame of the Great War. But physics works differently. Salt water is a catalyst. It eats through the steel casings of the shells. Corrosion acts faster in the deep than in the damp earth of the Zone Rouge. The metal thins. The seals fail. Toxins leak into the currents. The seabed is now a minefield of rotting iron. Between 1946 and the present day, 91 fishermen have been injured by these ghost shells. Trawlers drag nets across the floor. They pull up more than fish. A rusted cylinder breaks the surface. It leaks a thick, oily liquid. For the crew, the war begins again. Nature absorbs the poison. Animals die in silence. The legacy of the first industrial slaughter is no longer a historical footnote. It is an ecological time bomb ticking in the dark. This is the cycle of human innovation. We invent a way to kill, then we find a way to hide the evidence. Eventually, the earth and the sea return it to us. The ocean remains silent.